Hey everyone, it's Miss Brooks with your Daily Dose of Math. Today we're going to be taking notes on exponential notation. We want to understand what exponential notation is, be able to identify base and exponents, write things in exponential notation, and solve some basic exponent problems. So let's start by understanding exponential notation. So exponential notation is basically a fancy way of saying you have a number being raised to an exponent. We call this number the base. The base is the number that is being raised to an exponent, or the number that we're multiplying. And then the exponent, of course, the exponent is the small number stating how many times to multiply the base by itself. So as we go through, we want to be able to identify what is the base, what number are we actually multiplying, and what is the exponent, how many times do I need to multiply this number by itself. So let's take a look at number 1. We want to identify the base and exponent of these 4 problems. So in problem A, we have 1.2 to the 6th power. The base, what would actually be multiplied in this problem, is 1.2. And the exponent, how many times would I multiply 1.2 by itself, would be 6. In B, we've got -4 to the 5th power. In this problem, what number is actually going to be multiplied? The base, that's -4. And my exponent, how many times am I multiplying -4 by itself? That would be 5. In problem 3, my base, the number I would actually multiply would be 2. And my exponent would be 3. I'm going to multiply 2 by itself 3 times. And number 4, the base for -5 to the 4th would be -5. And my exponent, the amount of times that I'm multiplying -5 by itself, 4. Now in problem 2, we want to take the exponential notation and write it in expanded notation. We want to write out what would x to the 5th look like if we were to multiply that out. So in part A, x to the 5th, that would mean x times x times x times x times x. We're taking our base x and multiplying it by itself 5 times because that's what the exponent says to do. And letter B, y to the 7th. We're going to take our base y and multiply it by itself 7 times. So we'd have y times y times y times y times y times y times y. And letter C, we have 2x, that entire quantity, being raised to the 3rd. I know it's 2 and x because it's in parentheses. So this one, if I expanded it, would look like 2x times 2x times 2x. Finally, letter D, 5 to the 3rd, would be our base 5 multiplied by itself 3 times according to the exponent. So exponential notation is basically a shorter way of not having to write down all of the amount of bases we have. If we take a look at number 3, we're now going to take the expanded notation and write it in exponential notation. So what I'm given the base, and I need to find out how many times is it multiplied by itself and write that as my exponent. So in letter A, we've got 2 times 2 times 2. So my base is 2, that's what's being multiplied, and 2 is multiplied by itself 3 times. So in exponential notation, 2 times 2 times 2 would be 2 to the 3rd. Letter B, 23 times 23 times 23 times 23. My base is 23, and that's being raised to the 4th power because it was multiplied by itself 4 times. That's why I see 4 23s. Letter C, I've got 6 to the 3rd. D, I've got 5 squared. So I'm just taking the number and the exponent's how many times I see it. E would be 5 to the 4th. Now for a letter F, I've got -3 times -3 times -3 times -3 times -3 times -3. F, I've got to be careful. I need to put the -3 in parentheses to make sure it's a -3 as my base. And then my exponent would be 5. If I don't put -3 in parentheses, then I'm really just saying 3 is being raised to the 5th power. And I need to make sure this is a -3. That's why they were all in parentheses. For G, we've got 1/2 x times itself 3 times. So this is also one I'm going to have to put in parentheses because it's 1/2 x. It's not just one number as the base. And then this would be to the 3rd power. So if there are parentheses, there's more than one thing. We got to make sure we use the parentheses to keep it the same in exponential notation. And then for H, we've got x squared. Now, even though x squared didn't have parentheses around it, I'm going to put parentheses around it, and then my exponent would be 3. Because I don't want to put x squared immediately followed by 3, because then it's going to look like x to the 23rd, and that is not what was written down. So write in exponential notation, take your number being multiplied, and then put your exponent as how many times it was being multiplied by itself. How many numbers did you see? Our last problem, number 4, basically pulls all of this together. We want to write each expanded notation in exponential notation, and then identify what our base and exponent were. So I'm going to kind of combine all of this together. My base is always the number being multiplied. So in letter A, that would be 2. And my exponent is how many times that number was multiplied by itself. In this case, there were 1, 2, 3, 4, 5, 6 2's. So if I wrote this in exponential notation, this would be 2 my base to the 6th power as the exponent. And letter B, the one with the -4's. -4 is being multiplied by itself. That's my base. My exponent, it's being multiplied by itself 3 times. Now, when I actually write in exponential notation, I need to make sure to put the -4 in parentheses, and then the 3rd power. And letter C, what is being multiplied consistently each time is 2/3 y. So my base is 2/3 y. And it's being multiplied by itself 4 times. That's why I see 4 of them. So when I write this, letter C, in exponential notation, I need to put the 2/3 y in parentheses, because that's my entire base. It's more than one thing. It's not just 2/3, it's not just y. And then my exponent would be 4. Lastly, in letter D, with the w's, my base would be w, because that's what's being multiplied by itself. My exponent would be 4, because I see 4 w's. So this would be w to the 4th in exponential notation, rather than w times w times w times w. So again, exponential notation is a shortcut to writing out the expanded form and how many times I actually was multiplying something. On the back of this note sheet, I'm just going to do a few examples from number 5 and number 8. I really want you to try to discover yourself what happens when you simplify expressions that involve multiplication and division. So I'm going to get you started, and then I want you to go through the rest of the sheet and see if you can figure out what is happening in each problem. So let's look at number 5. I'm going to do A through C with you. So letter A, according to the directions, we want to expand and simplify the given expression. So we have a final answer with one base and one exponent. So if we look at letter A, we have x to the 4th times x. I'm going to expand this. I'm going to write what x to the 4th would look like. X to the 4th would be x times x times x times x. And then that's also being multiplied by another x. So if I count up how many x's I have all together, this would be my base is x. And how many x's do we have all together? 1, 2, 3, 4, 5 to the 5th power. So x to the 4th times x would be the same thing as x to the 5th power. Let's take a look at letter B. We have y to the 4th times y to the 3rd. So I'm going to expand this all out. and then write one final exponential expression. So y to the fourth would be y times y times y times y, 4 y's, times y to the third, which would be y times y times y, 3 y's. So I have all together, my base is y, and I have 1, 2, 3, 4, 5, 6, 7 y's. So y to the fourth times y to the third would be the same thing as y to the seventh. Let's take a look at one more. C, we have c squared times c to the fifth. So c squared would be c times c, and c to the fifth would be c times c times c times c times c. So this whole time in letter C, my base has been C, and I have 5 on the right, 1, 2, 3, 4, 5, and 2 on the left. That would make 6, 7. So I've got c to the seventh would be my exponential notation. So I want you to finish D, E, F, G, and H, and then answer number 6 and try the problems on number 7. Now, before I leave you to do the rest of the back by itself, I also would like to take a look at the problems on number 8 with you. So I'm going to do the same process with number 8, but number 8 you see a bunch of fractions. So we're dividing, whereas in number 7 we were multiplying. So let's look at number 8, the division problems. We're going to expand and simplify, so we wind up writing a final answer with one base and one exponent. So letter A, we've got x to the fifth over x squared. So x to the fifth, that would mean x times x times x times x times x. I'll put it on the left because I was running out of room. Over, on the bottom, we have x squared. X times x. Now, the neat thing about division is if you have the same thing on top and bottom, those things are going to cancel out and give you a value of 1. So right here, I have a pair of x's that I can cancel out. That's going to be 1. And over here, I have a pair of x's that'll cancel out. That's going to be 1. So if you notice, the entire bottom of my fraction has disappeared. And all I'm left with is 3 x's on the top. So x to the fifth divided by x squared would be the same thing as x to the third power, since I only have 3 x's left. Let's also look at b. We've got w squared over w to the seventh. So that would be w times w for w squared over w times w times w times w times w times w, 1, 2, 3, 4, 5, 6, times, I gotta go to box A a little bit, w. So I can do the same thing. Anywhere top and bottom are the exact same thing are going to cancel out and give me 1. So right here I got some w's that cancel out. Over here I got some w's that cancel out. Now, my whole entire top of the fraction is gone. But we can't just cross out the top and be like, no more top of a fraction. Bottoms are okay, but tops you got to keep. So, on the top, if these were canceling out to be 1, on the top I've got 1 left over 1, 2, 3, 4, 5 w's. So over w to the fifth. So this one I had more w's on the bottom. So the top became a 1, and then w to the fifth was what was left on the bottom. In A, there was no 1 over because the top had more. Let's take a look at one more. Letter C. We've got a to the 8th and a to the 7th. So that would be 1, 2, 3, 4, 5, 6, 7, 8 a's on top being multiplied together. And on the bottom, 1, 2, 3, 4, 5, 6, 7 a's on the bottom being multiplied. So again, I can cancel out every pair I have of the same thing, top and bottom. So goodbye to that pair of A's. Remember, they're canceling a 1. Goodbye to those. Look at that, my entire bottom canceled out. So bottoms, again, it's okay for those to go away. Doesn't affect anything. But the top, all that's left is A. So a to the 8th over a to the 7th would simplify to just a single A. So what I would like you to do is finish, in addition to the top problems you have to finish, also finish D, E, F, G, and H down here, answer number 9, and give the ones on number 10 a shot as well. And then we'll come together and talk about what you guys have found. So this concludes our lesson on the intro to exponents. We're going to talk about our different rules a little bit later, and I'll catch you next time on your Daily Dose of Math with Miss Brooks.